mean value theorem for integrals. So I'll just try to draw like a curvy thing. I'll just draw something like this time. Okay, so let's say you're going to integrate this from point A to point B. Okay? Integrating would give us the area under that curve, right? It would give us the area underneath. Well, what the mean value theorem for integrals does is it tells us there's some point C that we're going to find. The mean value theorem is going to tell us to find some point C that's between the A and the B. And it's a spot where it kind of makes a rectangle. You'd make a rectangle that goes through point C, like this. Okay, so I kind of went in the middle of that curve, just to show you for an example. So they're saying there's some point C where if you make a rectangle like that, this rectangle I tried to draw in red, that rectangle is the same area as the area under the curve. Well, why is that? It's because, like, okay, the rectangle I made, it sticks up above the curve right there a little bit, and it's a little bit below the curve right there, but doesn't that kind of even out the area? Like, see, like I tried to draw it. I'm not the best drawer, but like this area, that sticks up above, but isn't that kind of the same as that? So the area of that rectangle is the same as the area under the curve. So the mean value theorem says there's some place C that you can find and make a rectangle, so the area of that rectangle is the same as your area under your curve. All right, so here's the actual theorem, the actual formula. It's an integral from A to B, f of x dx. That's representing your integral, your area under your curve, is equal to f of c, like this height, f of c, like how tall this rectangle is, f of c, and then how wide is this rectangle? Because, you know, base times height, it's just like base times height. It'd be b minus a. Like, how long is this? B minus a, I don't know. We'll figure that out. The length times the height. It's just like base times height. The base is b minus a. The height is f of c. This is just like base times height of a rectangle. All right, so this is the formula. So let's go ahead and try this mean value theorem on an actual problem. Let's say you had f of x equals the square root of x. And I want to look at this function on the interval 4 to 9. A to B. I want to see if I can use this mean value theorem formula. You have to use this entire formula like this and see if we can solve. And we're going to try to solve for C. We're going to try to figure out what C is. Like, where is the spot between A and B where it has a rectangle with a certain height? All right, so we need to follow this formula. The left side of the formula says you're going to do an integral. So we want to integrate from 4 to 9, because that's the A to B numbers they gave you. From 4 to 9 of square root of x dx. Then the formula for mean value theorem, then it says equals f of c. Okay, we don't know what c is. F of c, that means like go to this function. That our function was f of x. It means to like put c in instead. Put in f of c. Like plug a c in right here. Instead of x, put a c. So it's going to say, yep, square root of c. F of c, it's going to say square root of c. And then b minus a. Well, let's see, b was 9, a is 4, so it's going to say 9 minus 4. Now, if you work this out, we should be able to get an answer. So this side you're going to have to integrate. That's like x to the 1/2 power. So we're going to have to integrate that. We're going to have to add 1 to that power. X to the 3/2 power. Then we have to divide by the 3/2. So that's like times 2/3. Yeah, so it'd be 2/3 x to the 3/2. And we're going to evaluate that from 4 to 9. So you're going to have to plug in 9, f of 9 minus f of 4. You're going to have to plug in 9 in there and plug in 4 in there and then subtract and get that answer. And over here, on the other side of the problem, you still have this, let's see, 9 minus 4 is actually 5, right? So it's like 5 square root of c. So this side still says 5 square root of c. But yeah, this side where the integral is, you're going to have to evaluate your integral. So let's see, if you plug in 9, I think you get 18 if you plug in 9. And if you plug in 4, I got 16 thirds. So you have to take 18 minus 16 thirds. 38 thirds equals 5 square root of c. And we're trying to figure out what c equals. So you have to keep going. What do you do next now to find c? Yep, divide by 5. So 38 thirds, you divide by 5, that'd be 38 over 15. If you divide by 5, it'll be 38 over 15. So you divide by 5, divide by 5. Now you have to get rid of the square root, square both sides, and you'll get the answer. You can put it as a decimal. I think they approximate it on the assignment too. They let you put decimals. So 38 over 15 squared. Let's see what that is. Okay, it's about 6.42. Okay, so yesterday I did this too. I went to Desmos and showed them like what we're actually finding. Like it kind of makes sense too when you see it on the picture. Here, so I'll go to desmos.com really quick. Graphing calculator. So this function we started with was a square root of x. So I'm just going to type in square root of x. I'll go over the computer and show you. Just real quick, it won't take very long. So we were looking at this square root of x function, right? And we were looking at it from 4 to 9. So I'm just opening this because then I can draw on the screen. It's easier. Just takes a second. Okay, so we're looking at the picture from 4 to 9. So I'm just going to use my finger. 4 right there. 9's over here. See, 4 to 9. 9's about there. 4 to 9. So you're looking, that was the picture. So we found a spot in the middle. We found a spot at 6.4 that if you make like a rectangle there, it's about the same as the area under the curve. That's all it is. It's kind of weird, isn't it? So I could try to draw it. 6.4, I mean, it's kind of close to there. I don't know. I'm not going to be able, I'm just sketching. So it's like if you made a rectangle. Sorry, it's bad. But yeah, it's like the area there and that, they're kind of the same. That rectangle is like about the same as the area under the curve. So where C is, so C is a point, see on the x-axis, 6.42. It's a spot down here on the x-axis. The C number you're finding is on the x-axis. Like where, somewhere in the middle, where you can make a rectangle with a certain height. So yeah, C is an x coordinate. It's on the x-axis. Okay, so then there is a second part that's called the average value of a function. There's just another step to this. So some questions will ask you to use this mean value theorem to find C, to solve and find C. So we just did that. Some questions will ask you to find the average value of a function. All right, so I'll draw on the back of this. Okay, average value of a function. Average value of a function. Okay, this is, I mean, if we refer back to the picture we just had, this is like finding the height of that rectangle. We just found like C is 6.42 on the x-axis. Well, then what's the height, like the f of C? It's like finding f of C. So average value of a function, goes 1 over b minus a. It's another little formula we got to use. And you integrate from a to b some function. Okay, this is the average value formula. How do you find the average value of a function? You use this formula. So it's like all you do is integrate it and then times by 1 over b minus a. It's pretty easy. So let's try one. If you have 3x squared minus 2x on the interval 1 to 4. Let's try to find the average value of the function on the interval 1 to 4. Okay, so you integrate it from 1 to 4, and you have this function 3x squared minus 2x. So I always think about integrating it first, then at the very end, you're going to times by 1 over, what's b minus a? Yeah, it's 4 minus 1, which is, yeah, it's like 1/3. Yeah, it's like 1 over 3 in the front. So yeah, it's going to be 1/3 times whatever the answer is from this integral. All right, so let's integrate. So you add 1 to your power. Yeah, so what do you get? X to the 3rd, yep. If you add 1 to your power and then divide by 3, it'll cancel that 3 out. Minus x squared, yep. Then we're going to integrate that from 1 to 4. So plug in 4 into there. Yeah, 64 minus 16 is 48. And then plug in 1 into the problem. Yeah, 1 minus 1, that's 0. Like 1 to the 3rd minus 1 to the 2nd is 0. Okay, so it's just 48 for, f of 4. It was just f of 4 minus f of 1. We were just plugging those in, and we got 48 and we got 0. So that's good. So then you just times by 1/3. What's 1/3 times 48? 16. Okay, now what is that answer? Just so you know, that is not an answer on the x-axis. That's like the height of the rectangle that we make. Like if I draw a picture of this thing again, I think they had a picture in the book, so I don't have to draw it myself. Sometimes after a while I'm like, I don't want to draw that thing. Let me show you the picture in the book. So, they have it in the book here. This is the problem we just went over. So they graphed 3x squared minus 2x, it's this curve, and you just found the average value 16, that's the height of that rectangle. It's not the x-axis answer, it's the height of the rectangle. So the average value finds the height of the rectangle that approximates the area. And the first theorem, the mean value theorem, found the spot on the x-axis where there is that rectangle of a certain height. You could find the point on the x-axis where the height is 16. You could, if you wanted to, you could take this answer 16, because remember that's the average value, so it's like an average height. That's like a height on the... You could take that 16 answer, and you could just say, like, this problem equals 16, and you could solve it, like, with quadratic formula or factoring. You could find C, the point on the x-axis, if you wanted to. Because I do think there is some problems that want you to find both. So if you did find that C, that height of that rectangle, you could equal the original problem to 16 and figure out the answer. It's possible. You would have to minus the 16, equal the problem to 0. Then I'd probably do like the quadratic formula, which actually Algebra 2 was just doing. I had it on the screen when you guys came in. So it was negative b plus or minus square root of b squared, so it'd be negative 2 squared, b squared minus 4 times a times c all over 2a. You would have to do that if you wanted to find the c number, the point on the x-axis where you have the height of 16. So it would take a minute or two to type this all in. Let's see, negative 2 squared minus 4 times 3 times negative 16. Do all the math. So I got 2 plus or minus square root of 196 all over 6. Square root of 196 is 14. So 2 plus or minus 14 over 6. So you could figure it out. Divided by 6. So if I add 2 plus 14, I get 16. 16 divided by 6 is 8 thirds, 2.6 repeating, or 8 thirds. That'd be the point on the x-axis where you have that rectangle of the height 16. So hopefully you kind of get it, like, it's just finding this rectangle that has the same area as the area under the curve from A to B. So those two, the mean value theorem and this average value function, they do kind of go together. So actually this average value function, just to kind of show you, look at the mean value theorem and look at the average value function. Okay, they both have an integral in them, see that? And this has f of c times b minus a. This has 1 over b minus a. It's like all they're doing is moving the b minus a over to that side. See? 1 over b, divide by b minus a, and you get the f of c, the height of the... So they are very related to each other, those two formulas. Yep, that's how they got the average value formula. They took this one and divided. So, all right, so that's the first two things. Now there's one more thing. There's the second fundamental theorem of calculus. This isn't too bad either. Okay. The first fundamental theorem of calculus, you already learned that, actually. I don't know if this whole section is called the fundamental theorem of calculus. You've been integrating now and finding f of b minus f of a. That's the first fundamental theorem when you've been doing these integrals and evaluating them. So now what's the second fundamental theorem? Second fundamental theorem. Okay. So, like we said, you have already been integrating. You've already been integrating, like, from a to b, some kind of function with respect to x. Okay, so you've already been integrating. When you integrate, you get back that original function. You know, it's like working backwards, getting back the function like before you took your derivative. So the second fundamental theorem, what that does, it helps you find, what this theorem does is it helps you find f, capital F, this capital F prime of x. What this second fundamental theorem does is it helps you find this. Now, I don't want to just reveal the answer yet. Like, there is like a shortcut to this, but I want to show you like the long way first. So let's say we were integrating some kind of function. Okay, so we're trying to find the original function again. And let's say we're integrating something from -2 to x. And then I'll put 3, I'm going to use a different variable. They do that sometimes. Let's put 3t plus 6 with respect to t, dt they put. Okay, so we've already learned about how to integrate. Now this time I didn't go from a number to another number. I went from -2 to x instead of like -2 to 5 or -2 to 4. Okay, so the second fundamental theorem, it usually does have a variable up here, like some kind of variable, instead of like a number to a number. Well, let's go ahead and integrate this and do it like how we've learned. Let's see, how do you integrate 3t? Yeah, you add 1 to your power, so it's t squared, and then you divide by 2. Good. How do you integrate a 6? Yeah, you add a variable to it, and our variable this time is actually t, so it's going to be 6t. I know it's like common to say 6x, but it's with respect to t this time, so it's 6t. Okay, now let's evaluate that from -2 to x. So instead of plugging in a number at the top this time, now we're putting in an x. So it's going to be, finding f of x minus f of -2. So let's see if we can do that. All right, so plug in an x. So it'd say 3x squared over 2 plus 6x, right? Now let's try to plug in -2 into this, and we'll get some numbers. Okay, so you said it'd be like -6 for this whole thing, but it was minus this -6, so it'll be plus 6. Good. Okay, so you're getting at 3x squared over 2 plus 6x plus 6. Okay, that's f of x. That's this capital F of x. So when we integrated, we got back to the original function. Okay, well, what's the second fundamental theorem want you to do? They actually want you to find f prime. Like the capital F, this is this capital F function. We found it, we integrated. Now they actually want you to take the derivative of this. What happens if I take the derivative of this? Okay? Yeah, you bring the 2 over, we take derivatives again. So take the derivative, you bring the 2 over. What do you get? Uh-huh. 3x. Okay. What's the derivative of 6x? What's the derivative of a plane 6? 0. Okay, now we went through all of that. What just happened?
We literally changed the piece to x.
We literally got back to, look at that said 3t plus 6. This says 3x plus 6. Okay, so I went through it all once. You're not going to have to do all that on your assignment. Guess what you have to do to get the answer? It's so easy. Yeah, all you're going to have to do, the second fundamental theorem is weird. You integrated and then you took the derivative again. It got you back to where you started. You're just going to change the t to an x. Yeah, so if they tell you to do the second fundamental theorem, you're just going to change the t's in this problem right here to x's.
So just change to whatever variables they want. Like if they wanted like an a, we just change it to x.
Yeah, yep. Now, there's one trick though. There's one more thing I gotta tell you before you go to your assignment. If that's not just a plain x, if that's just not like a plain 1x or 1a, then there's a trick. There's the chain rule. I'll show you really fast so it's easy. Okay, let's say instead of just an x there, let's say it went from -2 to x squared, let's say. See, it's not just an x, it's x squared. Okay, let's do the same problem again even. So we don't have to do the whole entire process like I just did a minute ago. So all we're going to have to do is plug this in, like we said. So it's going to be what? 3x. Okay, then take that, and then you have to times by the derivative of x squared. That's the chain rule. So there is chain rule with these integrals sometimes, and we're going to get more into chain rule after Thanksgiving, but this is like the first introduction to it. Yep, and then you'll have the answer. So yeah, if it's not just a plain x up there, if it's something else besides a plain x, you plug it in, then times by the derivative of that thing up there. Not that hard though. So yeah, distribute, and you'd have what, 6x to the third plus 12x. That'd be the answer.
So if it's like 3x, the derivative of 3x is x.
Yeah, then it'd be like times 3. Uh-huh. So yeah, there is a chain rule to this. That's the only thing that we'll have to remind you about, chain rule. And we'll do more chain rule type stuff after Thanksgiving. That's like the last lesson of the chapter it's called use substitution because there's chain rule stuff involved. So yeah, you guys are good. So that's everything for today. You could work on the problems out of the text.